Hello, my name is Brian Gomer. I want to welcome you to another in the series of updates for the spectrum ownership landscape. What we're doing in this particular episode is to go through a few more examples of how to utilize the spectrum landscape to understand more about wireless carriers and the spectrum that they own and control. Before we jump into it today, we're going to go through just the legal actions. So we've got a slide up on the screen that talks about our intellectual property statement. All of the reports, the formats, technical concepts, methods, processes, and procedures discussed in the following presentation are subject to a provisional patent that will be vigorously defended. Now we'll go ahead and jump in to the spectrum landscape. I have just one example today that I want to walk through that's actually in the spectrum landscape, and then we'll go on to some of the carrier summaries. So what we're going to walk through today is just, again, what the visual layout of the spectrum landscape helps us to see. I'm going to take us down here to the Los Angeles market, where Verizon holds the E-Block PCS spectrum and Metro PCS holds the C3 spectrum. With Metro PCS going to T-Mobile, this is a place that I would expect that T-Mobile and Verizon will want to make a trade and reconfigure their systems so that T-Mobile will actually have 15 megahertz of contiguous spectrum here, and Verizon would have the same, that they won't have these isolated pieces of spectrum. Obviously, if we kind of continue with that idea, Sprint out here with the PCSG would love to find ways to get some of these spectrum blocks to become contiguous with that 5 megahertz, just so they could then have a 20 megahertz channel at some point in the future for LTE. The primary purpose for this chart was, also to look at the AWS spectrum. It's a little easier for carriers to do those types of trades on the AWS spectrum, but you can see where Metro PCS and T-Mobile will end up in New York getting that contiguous spectrum, as well as here in Los Angeles. But there's challenges around this Philadelphia market, where they will get this Metro PCS piece, which is isolated from a very small T-Mobile piece. So this, I would highlight that the Philadelphia market would appear to be one of the markets that T-Mobile will not be able to both launch LTE, except with a very small 5 megahertz carrier, and it will not be on their list of 20 megahertz carriers unless they were to do a transaction with Leap. That Leap spectrum holdings here is very strong. Now the next example that we're going to walk through is to go into these market by band summaries, where we can first of all see the total megahertz for individual carriers. So we're going to go ahead and come across here, and so today it is set up so that it's looking at all of the national and regional players, as well as one or two of the satellite companies. What I can do is put in a couple of the more rural carriers for us to get a sense of where they operate and how much spectrum they have. So what I've chosen to do is to input carrier code C1, carrier code C2, carrier code C4, and carrier code CS. So what you can see with this is, first of all, the names show up, and it's obvious that C1 is Cellular One of Illinois, C2 is Cavalier Wireless, C4 is Carolina Wireless, and CS is Cellular South And they don't own any spectrum in the top markets that we're seeing there. So let's go ahead and do an auto filter and look for where Cellular One of Illinois operates. So we're choosing the places that their spectrum is not equal to 0, and you can see that they operate in these 2 RSAs in Illinois, and they have 25 megahertz of spectrum. Maybe the other piece that's kind of interesting is that Cavalier Wireless as well is operating in those markets as well, but they only have 10 megahertz of spectrum. Let me go ahead and get a better sense now of where does Cavalier Wireless typically operate. By turning off the zeros, I will see their spectrum positions in all the remaining markets. So Cavalier Wireless is in Cincinnati, Buffalo. You can see the list of markets all the way down the list here. In some of the more large markets, they have relatively small spectrum positions. And if you're then curious of what those spectrum positions relate to, we can come over here to the 700 meg, and you can see that their Buffalo, New York spectrum is 700 meg spectrum. Their AWS spectrum in Boone County is here. I'll go ahead and take this filter off. There's a little bit simpler way to actually look and see what each carrier actually owns and controls. So I'll have to turn on some auto filters here. So if we want to know where Cellular One actually, Cavalier Wireless is a little bit more interesting. So we're going to choose their non-zero markets. And now you get a really clear picture of what's going on with Cavalier Wireless, what markets they're operating in, and then as you go across, whether they own 700 meg spectrum, whether they own AWS spectrum, PCS, satellite. So what it really does appear is that they're predominantly a 700 meg cellular and PCS spectrum owner and operator. So now we'll go ahead and flip back to the market by band to actually see the megahertz pops. So the megahertz pops is over here on the right hand side, the far right hand side of the spreadsheet. If we scroll back just a little bit, you'll see where we made the selections of the carriers that we wanted to see highlighted. So again, we had Cellular One and Cavalier, Carolina, and Cellular South. So as we scroll out here to the megahertz pops range, you can see that in New York or New Jersey that none of those carriers have any spectrum. We'll go ahead and go with Cavalier Wireless and select something that it does not have a zero entry for. And now we actually see the megahertz pops values for Cavalier Wireless in Cincinnati, Buffalo, and all these other cities. Go ahead and unselect those and select Cellular South to again see which markets they operate in. Okay. Now the other piece that we have available is on the far left hand side of this spreadsheet the data includes a FIPS code, and with that FIPS code gives us the ability to map any of this data, the megahertz pops data per carrier by county, all the way to a geographical database. So a couple examples of what this output could look like are now shown. This is AT&T's total spectrum by county, and again, if you're familiar with GIS programs, you can customize the legend and the coloring so that it has more natural breaks, 100 megahertz, 120. Basically for this, it shows AT&T's deepest spectrum position in red and their least deep in the brightest green. So again, you can see easily, the Florida metropolitan areas, the Houston metropolitan areas, all of California, the I-5 corridor of Seattle, all that have very deep spectrum positions, as well as strong spectrum positions up in the Northeast. Sprint's total spectrum position has a little bit different range, but you can see that where AT&T prior had all the way up to 178 megahertz in some markets, Sprint's maximum taps out at 81. Obviously this is without Clearwire, but this is part of the analysis that the merger will be going through. But again, Sprint has a very strong spectrum position, or a stronger spectrum position in this North Texas, Oklahoma area, and then even lighter positions. That's about 20 megahertz more in depth. Again, one of the reasons I emphasize being able to look at spectrum from a lot of different perspectives, that perspective of Sprint having 20 megahertz additional spectrum in just a very limited region or two regions is something that doesn't necessarily stand out when you look at columns with columns and rows of tabular data, but it becomes very obvious to the eye when you look at a geographical map. The last map to show is Clearwire's total spectrum depth, and what this really illustrates again is that Clearwire spectrum depth again could go all the way up to 186 megahertz, but it is most concentrated in the large cities as well, and that the rural areas actually have very light 50 megahertz or less type spectrum ownership. Well, that wraps up this analysis. Thank you again for tuning in, and the next video will walk you through the EBS-BRS spectrum gradient.